So this is my module 2 about moderation and mediation. So first, I just want to talk about the moderation model. So a moderator is a variable that affects the direction or strength of the relationship between the predictor variable, so x, and a dependent variable, y. As Barron and Kenny in their 1986 article explained, there are 3 causal pathways in a moderator model. So first is the relationship between x and y. Second is the direct effect of the moderator on y. In this case, the moderator is m. And third, the interaction effect, which is a product of x and m. So Barron and Kenny said that if the interaction effect is significant, then the moderator hypothesis is supported. So to test for moderation, you can use the equation that I have shown below. And this I just went ahead, as we did in class, and redistributed it into the simple slope and simple intercept equation format to really help me personally understand how the proposed moderator may impact the regression model moving forward. So overall, I ran through 3 different moderation models to show what happens when there are different parts of it that are significant or not significant. So in the 3 models, I have one continuous variable, a moderator, which is a dichotomous or a binary variable, and then the independent variable, in this case y, is a continuous variable. Important to note is when I created the variables, they were created with a mean of 0, but otherwise predictors should be centered to help with interpretation. So for the first model that you can see here, I wanted to have a significant B1, B2, and B3, but a non-significant B0. So the graph to the left shows what I expected my results to look like. So since B0 in this model was not significant, I expected that the intercept when the mediator variable, so x2, was 0, to be 0. But then, because B2 was significant, I expected a shift in the intercept when x2 equals 1, because B2 is significant, as I said. So also, since there is a significant interaction effect, B3, I expected to see a change in slope between when x2 equals 0 and when x2 equals 1. So on the right, you can see the results from when I actually ran the regression. So you can see that everything indeed was significant besides B0, the intercept. And also when I did the graph in R, you can see that the graph looks very similar to what I expected it to look like. I also ran the regression diagnostics, and everything looked generally okay. There were a few data points that looked like they may be slight outliers, but overall they really weren't influential. So overall, the model met the Gauss-Markov regression assumptions, and I believe that it is a best linear unbiased estimate. So for my second moderation model, I wanted a significant B0, B1, and B3, but a non-significant B2. So again, the graph to the left shows what I expect my results to look like. Since B0 is significant, I expected that the intercept when the mediator variable x2 equals 0, when that was the case, that the intercept would be greater than 0. But when x2 equals 1, I did not expect to see a shift in the intercept because B2 is not significant. Also, since there is a significant interaction effect, B3, I did expect to see that change in slope from when x2 equals 0 to when x2 equals 1. So on the right, the regression results show that the intercept was significant, x1 was significant, and the interaction, x3 was significant, but, and these are in B's, and then B2 was non-significant. So you can see that the graph as well looks similar to what I expected. So I also ran the regression diagnostic, The normal QQ plot was a bit off around the tails, so the residuals may not be fully normally distributed, but overall things look good enough that I believe that this is the best linear unbiased estimate for this model. So then I ran a third moderation model. In this model, I wanted a significant B0 and a significant B1, but a non-significant B2 and a non-significant B3. So the graph shows what I expected my results to look like. Since B2 is significant, I expected the intercept when the mediator variable equals 0 to be greater than 0. But then I did not expect to see a shift in the intercept because B2 is not significant. Also, since B3, the interaction effect was not significant, I did not expect to see a change in slope. So in this case, there should be the same slope when x2 equals 0 and when x2 equals 1. So it's a little bit hard to see, but they're basically right on top of each other, these two lines. So the regression results to the right show that the intercept and B1 were significant and the other parts of the model were not significant. And the lines also show the same thing, that there is really no significant moderation effect because the interaction is not significant. I ran the regression diagnostics for this model as well, and everything was also generally okay. So now turning to mediation. So per Barron and Kenny, a mediator accounts for the relationship between the predictor, so X, and the criterion, so Y. And mediation is a causal model, so the mediator in this case is presumed to actually cause the outcome. So in comparison to moderation, which we were just talking about, a moderator variable specifies when certain effects may hold, but a mediator really speaks to how or why such effects occur. So as we can see in this image, there are two causal paths in a mediation model. So the direct impact of the independent variable X on Y, which is represented by C prime, and the impact of the mediator on Y, and this is shown as path B. And then there is also a path from X to the mediator, and this is path A. And these are compared to, as you can see below, the direct effect, which is just showing the path between X and Y, and this is represented by C. So it's important to note that C prime is different than C because C prime is a partial correlation coefficient. So Barron and Kenny also explain that a variable functions as a mediator when path A and path B are significant, but path C prime is no longer significant, so it's approaching or it really is 0. Also, just important to note when you're dealing with mediation models, if M is a successful mediator, it's basically necessarily correlated, so collinear with X. And this ultimately impacts the precision of the regression equation when you are testing path B and C prime, and can result in low-powered results if there's only a small sample size. Also, just another note, the model here only has one mediator, but the Preacher and Hayes article discuss multiple mediator models. So I ran two different mediation models, and this is the first model that I ran. So Barron and Kenny suggest that when you're running a mediation model, to test for mediation that you do 3 steps. So first is to test for the direct effect with X as a predictor of Y, and this is path C from the previous diagram. And then the second step is to test for path A, and that is how the independent variable affects the mediator. And then the third step is to test for path B and C prime. And this is running a regression with X and M predicting Y to show that the mediator actually affects Y. So I know that some folks, the first step may not be necessary, but in these models, I have gone through all 3 steps that Barron and Kenny suggest. So as you can see in this model, C was significant, path A was significant, path B was significant, and path C prime was not significant. So in this example, the model can be considered fully mediated because path A and path B are significant and path C prime is essentially 0. However, if path C prime was not 0, the model technically would be considered only partially mediated. Also important to note is when I ran the diagnostics, you can see that the variance inflation factor between X and M is large. In this case, it's around 4.6. And this is because, as I talked about before, X and M are collinear. This is what you would expect if the mediator is significant. So overall, it's just important to note the variance inflation factor because there means that there could be some imprecision of estimates in the coefficients because of this collinear relationship. So I also tested the indirect effect of my first model. So I first conducted a Sobel test to test the indirect effect. And the Sobel test is calculated by dividing the amount of mediation. So the indirect effect, which is equal to A times B, taking this and dividing it by the standard error of A times B. And this gives you a score, which is essentially a z-score that can be used to find a p-value. So I found a value of 8.8, which had a p-value that was essentially approaching 0. So for my first model, I failed to rule out mediation. So we can consider mediation as a potential effect in this model. The Kenny website also explains that the Sobel test is conservative, so overall it tends to have lower power. So this is just something to keep in mind. I also did a bootstrap to test the indirect effect. So bootstrapping is just resampling with replacement many times to get a sampling distribution. And then I looked at the 95% confidence interval of the sampling distribution to see if 0 fell within this confidence interval. And we can see that the confidence interval did not include 0. Therefore, I conclude that the indirect effect is different than 0. So now looking at my second mediation model. In this model, path C is significant, path A is significant, path C prime is significant, but path B is not significant. So because path B is not significant, we do not have a mediation effect. So I also did a bootstrap test, as I talked about previously. And when we look at that 95% confidence interval, you can see that 0 falls within the interval. So we fail to reject the null. So in this case, in this model, we can rule out mediation. Again, similar to my other model, I ran diagnostics and noted that there was a fairly high variance inflation factor. This is because, as we can see, there is a significant relationship between X and M. They are collinear, so this is what is expected. And just to sum up, this was my presentation of mediation and moderation for Module 2. Thanks.